Feng's the founder and CEO of ReynCon Educational Services and Training, and is joined by Jason Montgomery, who is their director, CISO, principal technical consultant, course author, instructor. Collectively, there's a combined just almost 60 years of cybersecurity experience and expertise on this stage, and I don't have any of that. That's those two opposite stage. So I'm going to, round of applause. Thank for Connie and for Jason for being here with us. Connie is she's very near and dear to us at FutureCon. She's always so amazing at helping elevate these conferences with an amazing lineup of panelists. At the end of the day, I think you keynoted for us a few times before. So thank you for being back with us. We love having you. And the hour is yours as they take us through GenAI and deepfakes.
All right, so we're going to start with a few questions, and we want this to be interactive. So if you have a question, feel free to stop us at any time. So my first question is, by show of hands, how many of you use GenAI personally? And then keep your hand up if you use it every day. So a little bit less people. Okay, then the second question, so it would be, how many of you are using it in your work environment for the companies you work for? So probably about 50%, looks like. Yeah, so. All right, most of you know both of us, so we won't bore you with our backgrounds. But when he said we had 60 years, that just means we're old, so.
That's right.
We've been around for a while. So really, again, we want this to be interactive, and we're just going to kind of walk you through a journey. Jason is going to kind of show some demos, and he hates when I do this, but the feedback we've been receiving, even from companies like Google, that Jason is probably one of the best GenAI, LLM, app security people in the world. And I truly believe that. I have the privilege of working with him all the time. But he's phenomenal with this topic. So if we don't know something, obviously it's changing every single day. When we do a lot of this training, we find ourselves literally the night before making changes because of those changes that are constantly happening. So again, questions are encouraged. Feel free to interrupt us or just raise your hand and we'll answer anything. So thanks for joining us, and I'll go ahead and turn it over to Jason.
Thanks, Connie. Yeah, I wanted to spend a couple minutes on some general level setting on general terminology on the technology side. Most of us have used it, so I don't think I'll spend a ton of time on it. But just to, again, level set on everything. Generative AI, as we all know, is definitely taking the world by storm right now. It's kind of the next big evolution in technology. And when we talk about it here, it's effectively anything where you have an AI system that can generate or take input from anything across multiple modalities, and modality is just a fancy word for the format of the data. So it's text, image, audio, video, certain structured formats of data, which could be code, API calls, things that are very technical, as well as even 3D modeling now. Basically, we're saying in these contexts, it's content that was not explicitly programmed, but prompted or directed by natural language in most cases, or by some sort of text or audio or video or image input. Again, I might skip some of these slides for time, and because I think a lot of people already know this stuff these days. But the last decade of AI, I spent about a decade ago, I built a company that focused on machine learning, and we sold that to Data Robot. And effectively, that was my first introduction to AI, especially in the cybersecurity domain, as well as general application. And I want to talk a little bit about where we've come from and where we've ended up. And so we talk about these models or foundational models when talking about AI, and I just wanted to have a quick level set on what that means. And so effectively, in historical machine learning, we would take a whole bunch of data, many rows, hundreds, thousands, millions, and we would, just like an Excel spreadsheet, you have a bunch of columns, and these columns are effectively called features. It's just a fancy word for the column of data. And all these features would come together, and they would in this example here, you might have different environmental conditions, and then feature 4 is like what you might do on that day. So sunny, 75 degrees, you might go to the park. Or it's cloudy at 60, you might go to a restaurant. Just imagine you have a big, massive data set of these. It's a really simple, contrived example, but I think it makes the point. You would take all this data and you would show it to the model, and that's called training the model. Once you get all that data into the model, you end up with an algorithm. And then that output of that training set is the model itself. And then that model we can then make predictions with, or what they call inference. And a prediction is just, let's throw a few features in and see what likely is the pattern in the data to predict the final feature. And so that would look something like this. So you take feature 1, partly sunny, feature 2, et cetera, and then we want to predict feature 4. So maybe you want to figure out what to do today based on the weather conditions and some other conditions. And then the model, you pass that to the model, and the model would predict, go to the park. Pretty simple. This is a real basic example, but that's machine learning. And machine learning was incredibly limiting because we could really only deal with numerical values. So even when you saw something like partly sunny, that's mapped to a number real simply in the back end. And if you had like 20 different weather conditions, you would have 1 through 20. Those are the numeric values. The weather would be, the temperature would be similar, as well as all the features effectively get turned into numerical values. And then the prediction is the same way. You'd have a limited set of predictions, and it would predict one of those numbers and then translate it back to text at the end. And so that's just inference, and that's prediction. So that's machine learning. And I found it incredibly limiting. We tried to build a lot of technology on this, but ultimately it really wasn't ready for the masses. I think most of us found that it worked in statistical cases, it worked in business problems, anomaly detection for maybe fraud detection, things like that. So it's used in a lot of places where you're just dealing with numerical values. And you could do a little bit of natural language processing or NLP, but it was incredibly limiting. So generative AI models are similar, except instead of putting in a very discrete set or a limited set of numbers, we would pump basically all the world's written knowledge, all the images we could. We would come up with these massive data sets. And we would use that then through a neural net. And it would self-organize all this information in what we call a model as well. And it would effectively render these in a very high dimensional space. And it would cluster similar ideas and concepts together in this highly dimensional space, so that when we have certain inputs, the model is able to pay attention to all those inputs, figure out what all is the similar concepts, ideas in that highly dimensional space, and then make more logical predictions based on it through neural nets. And so when OpenAI trained GPT-3 in 2020, they took about 45 terabytes of written text, and they took probably 3 months of training on massive clusters of compute, and they ended up with what they call a foundational model. And these foundational models are all the things we build on today. So there's a whole bunch of them from, Anthropic has foundational models, OpenAI has foundational models, XAI, et cetera. So there's a bunch of companies who make these, but not a whole lot because it's incredibly expensive. Costs millions and millions of dollars to train. And so the rest of us are just going to build on top of these. And so you take a foundational model, you can either fine-tune that model, or you can leverage it with some clever prompting, which is effectively inputs to that model. And so once this data is self-arranged in the model, we can then go in and say, given this email thread, so the model would need to see the entire conversation thread in an email, we could just say, write a summary of the email thread. And based on the way the model weights are set up and the way the human language combines, and in many cases, it doesn't even matter which language you're using because it actually understands relationships between translations inherently. It works so incredibly well, and we don't quite understand why it works incredibly well. We just know that it does. And so you can do this, and effectively, you just get these nice summaries. So when you go to your Zoom meeting and you have your audio guy listening on the call, they do text-to-speech model. That text-to-speech model then passes this text into a textual model, and then it will do a summary task and break that down for us. That's effectively how these work today. And so the other interesting part is it's really just predicting the next token. So a lot of people want to associate some sort of clever thinking, even when they call them reasoning models. All we're doing is passing in a bunch of text. It predicts the next token. The next token is actually a subset of a word. And then we loop again. And then we append a word. We loop and predict again. And you're just predicting the next token. So it's a probabilistic output of the next word in a sentence. And the very early LLMs, you would actually start a sentence and it would finish it. And that was how we prompted back, in I think 4 or 5 years ago. Now we have audio, video, text, et cetera. Has anyone played with the new Sora 2 app and the video generation on that? It's pretty wild. It's very impressive. Also, VO3 from Google is incredibly impressive for real-time video generation. And some of it is trained and compute. Again, I want to jump into kind of get to the main part of the content just after some level setting there. The other thing to consider, and the reason I kind of went through that is to understand the training process and all the data and all the human knowledge we've put into these models. And they've read a significant portion of all of human knowledge. And so with that, we have different cultural contexts, different historical contexts. So if you ask a question, the level of specificity and the way you dial that question in will impart a particular output. So if I ask about the history of science over the last 100 years, it'll give me that history. But if I ask it to tell me about science, and I'm not very specific, what era of science am I going to get output from? What physics questions were unanswered when the model weights dialed into that question based on the way that I asked it? And so the challenge with that, as well as it's been trained on tons of fiction, it's also been trained on human data in forums, which have all kinds of different opinions and discussion and perspectives. And so this model is full of literally everything. And they like to talk about, oh, the model made stuff up and it's hallucinating. That's actually a feature. I wouldn't even call it hallucinating. If you're writing fiction, is it a hallucination? Probably not, right? The model doesn't also know the difference. It's literally predicting the next word. So it's a feature. The trick is when we use these models, how do we make sure we're getting reality that's grounded based on the topic we want to talk about? We might want to ground it in a fictional universe, or we may want to ground it in a reality, a security problem we're trying to solve, an email summary, et cetera. And so that's really the challenge, and that's our job with prompting, which is really the input that we type into the model, as well as the grounding, which is the ground truth of information we provide it so that it's grounded in the task at hand. So whether that's the email thread I was talking about, or whether a fictional universe or scientific history of the last 50 years, or literally what happened yesterday. Now, these models have cutoff dates of training, and so a lot of them used to say, I'm sorry, I don't know what's going on today. My model cutoff training date was 2024 of December, for example. And so if you ask it what happened yesterday, it doesn't know. And so what they've done is they've given the model tools, and they've exposed it to tools that then go retrieve based on, so the LLM knows you have a tool that can go retrieve the news for any day. And in the system prompt, they'll actually give it the date, so it knows the date. I wish they would do that in some of the other tools I use, because some of these tools still think it's 2024. So I have to ground it in the current date, and then it understands the reality it's working in. And so as we ask for information, we just have to remember all these things. The model is a probabilistic prediction machine, and it's only as good as the information we give it to ground it. So if you don't ground your AI and you ask a vague question, you're going to get a who knows what answer. And so a lot of people want to talk to it like another person. I would liken it more to natural language programming, or some sort of structured way to elicit the correct output. And we have lots of websites that'll teach you prompting techniques, chain of thought reasoning. There's all kinds of, and that's a really important one, but there's all kinds of these to figure that out. So we're not going to spend time on that today, but I always want to level set on that's how these AI systems work. And you have to be very careful and understand that before you actually use them day to day.
And then how many of you saw I think it was Accenture, right? That they got into in the UK. Oh, is it Deloitte? Maybe. But basically, they were using generative AI, and the report that they gave to their customer was completely wrong, and now they're being sued for that. And then we also, as a use case, there was an attorney that used GenAI to prepare for his case, and it was all false information. And he got pretty much torn apart in the court and by his peers, because again, I can't believe any attorney I know would never just take anything at face value, but he did. And so I think the big thing is, we keep hearing developers aren't going to have their jobs. And this is something that Jason does all the time, and he's shown me, and it's actually quite entertaining. So he'll ask, his prompt will be something, and it comes back and it's incorrect. And he'll say, hey, this is incorrect. And they're like, you're right. And then Jason will be like, well, you're the one that just told me. And so it's actually pretty entertaining. So you can get into kind of discussions with that. So I would also challenge everyone to just mess around with it. And like we use Claude, and they're all getting better. But one thing I do appreciate about Claude is it references where they pull the data from. And so when I'm doing research, if something seems off, I look where it's referenced from, and then I do further research with from trusted sources. So I think the thing is we all hear hallucination, garbage in, garbage out. Just because it's in there doesn't mean it's always right. And we don't live in a world of misinformation and disinformation at all, so just being funny about that. So I think we just have to keep in mind, and I look at all of this stuff as like another tool in your tool belt. I personally think that it's going to be leveraged from a sense where, for example, how many of you work in a SOC or have worked in a SOC? So do you get through all of your logs every day? No. So I see that type of ways of helping is being able to take very large sets of data and be able to rationalize it a little more. And I just think it's going to help us be more productive, and then we can potentially work on the things that actually make more sense. It's a little more fun. I always joke, if I couldn't work in a SOC, I'd rather poke my eyes out with a fork. I don't know how people do it, to be honest, but I'm very outgoing, and I'm like always go, go, go. But, that's why there's so much burnout, because sometimes you just can't get to the problem because there's so much noise. So those are just some things I would think about as, we're leveraging them. And the same thing with code. Many, many times, if you don't understand how to code securely, you're not going to know that there's things wrong. Because let's think about like the OWASP top 10. The bottom of top 10 have been around for almost 20 years. So with that being said, most people use libraries. And I can tell you, when I've done pen testing with my teams, we find the same mistakes every time they roll out an app, because they continue to go to the libraries. They don't fix the problems. So can you imagine like GenAI on major speed? It's the same problem still exists. So you have to check your work, but it does make it a lot more productive. And Jason will talk a little bit about how he's using it, where he can develop code way faster using it, but he still has to do those checks and balances when he's doing that code.
Yeah, we call that human in the loop, and that's a fundamental AI principle that's been around since it came out. And some of the agentic systems, which effectively means AIs run off, they have agency, they can kind of solve some sort of orchestrated problem on its own, and they can come back with some answers. But if you don't actually review how they got there, you can end up in a lot of trouble. And so here's a whole bunch of news articles already on people who put systems in production too quickly before they were ready. And the fake legal brief cases, we have the New York City's AI chatbot was caught telling businesses to break the law. Air Canada had to honor a refund policy. The airline's chatbot invented one. And the judge was like, your website told that customer that was your policy, so you have to honor it. And so he got some discounted flights. So, and the problem in most of these cases is that the AI was not grounded. People are not building robust evaluation frameworks to see how these systems behave in an incredibly diverse set of inputs, because we're dealing with natural language. And so I use AI a lot to write software, to perform pen tests, to do assessments, threat models. I use it in all these contexts, but I have to review every little bit it outputs. I have to check everything, because you have about 80 to 95% accurate output, and then you compound those with agents talking to agents, and you end up with some pretty big drift. And so you have to be able to dial it in and ground it in reality. All right, let's see where I jumped ahead to that news slide, because that was more appropriate. All right, so we want to talk about accelerating your teams. I've been really pushing on this really hard for the last 4 years. I had a generative AI company we ran for 3 years. We built a lot of the agentic technologies before it was called that. And so I have some experience with the challenges with that, as well as then once I left that company, I've been pushing it really hard and to its limits to basically validate the claims a lot of CEOs are making. You can replace half your teams, et cetera. And what I found is while you can accelerate work considerably, you can't take subject matter expertise out of the middle because you have to know what good looks like to validate the output. So there's a whole bunch of development platforms out there now like Lovable, Bolt, V0, Base 44, et cetera, that will generate a website or generate an application for you. And they found that when they push these to productions, they are full of security flaws, holes, bad architecture. It's a mess. And so if you're going to write code, you need an engineer who knows what good looks like. And so that's kind of the key. And they have to review all the code. And so I've been basically accelerating my work. And we wanted to talk through some of the use cases I found incredibly practical. Right now, people in enterprises are trying to operationalize. How do we put generative AI in and automate all these things and orchestrate all these things? And I think it's probably more powerful to put AI in your people's hands, educate them on the risks, the dangers, but the benefits, and have them use it and then have them evolve to a process that works. And so most of the risks right now are like these AI projects are failing or we can't deploy these things for all our teams to use. And it's like, did you ever think of just put it, and companies are doing this too, just put a chat bot in front of the people and have them build intuition. And that's effectively what we're saying. Use it, push it to its limits. Don't use it in production settings, but learn the edges, learn the boundaries, learn how to push it, and learn where it falls over, learn where it's really good, and then your people will start to innovate themselves. They'll understand the processes they can automate, and then they can start building systems with it. But we're not ready for, I think, all of that orchestration and automation yet. We have to crawl, walk, run kind of situation. And so I've been doing this for about 4 years now, and I have found that I can use it in almost every situation with these fundamental understandings to really accelerate the work I do. So I'm going to talk briefly about legacy systems analysis understanding, AI-driven threat modeling, AI-driven tabletop exercises, and AI-generated exploits and attack support. And so I've had several opportunities to use AI in pen testing, which was a lot of fun, and also use it to write. I've written entire full-stack systems that are in production that I've not written a line of code in. So it's possible to do, and I've reviewed it all, but I did not write any of it. And that was on purpose. I wanted to really test the limits of that. So that's probably, even having it generate code, I probably could have written normally, but I really wanted to see if this was a feasible task. It's not an easy task, and it can be a frustrating task at points, which is why you still need humans in the middle there. But this diagram here came out of system understanding that I had the AI build for me. And I've done a few engagements where we've had, and this is through other consulting arrangements in the AI space, where companies have 20, 30-year-old legacy code bases. No one knows how it works anymore at the company. It's written in PHP and old Apache and MySQL in some cases. Other examples, old Java legacy code. And so what do we do with these systems when, like, I've had people say, do we re-platform this? Do we keep maintaining it? We think we have IP in here, but we don't even know our own business process because the system does it for us. And I've been able to, with a week or two's worth of work, distill an entire system down into all its business logic using AI and actually create all the documentation that the developers never wrote, which is incredibly powerful. So this diagram is AI generated. And along with heavy documentation on business rules, et cetera. And then just another quick aside before we dive into that, and we want to talk about the attackers too, because they have this access. They don't have any of the constraints we do. They don't need to really put their stuff in production usually. They get to just play and see if they can break in. And the other issue is when you have AI built into your systems and you have attackers also attacking your systems with AI, you end up having the AI assistant, your own assistant turned into assistant to the attacker. And it actually has insider knowledge of the system and how it was architected. And if you don't have the correct checks and guardrails in there, they actually get a free assistant who knows your company's architecture and system design, an inside man effectively, that you can ask questions of, and it will actually help them further break into your network. So when ChatGPT-4 released their analytics, their first analytics platform about 3 years ago, they effectively are having an AI write Python code. They would deploy it to a container, and they would actually execute the code. And I said, this is a terrible idea. Effectively, I have a natural language arbitrary code generation engine running in OpenAI's cloud environment. So it's remote code execution is a feature. And they all do this now, and it was incredibly concerning at the time. So the guy I was working with at the time and I sat down. As soon as we saw this feature, we got access to the beta. They had all the guardrails supposedly and everything. And in about 20 minutes, we were actually in the containers writing and reading code files, source code in the OpenAI backend. And so when we initially tried to do it, we would have it generate code that would do something, but then it would always say, well, due to the restrictions in the environment, we can't interact with local hardware, devices such as serial ports, webcams. We can't access the local file system outside the current directory. And you can see here I have OpenAI returning the backend folder list of the Python routes and Jupyter notebooks that were built in there. And the direct attack on these systems didn't work. If I said, give me the directory listing, it would say I can't do that. But if I just said, hey, what errors would this program you just wrote, you won't run it, but what errors would it generate? And it was like, I don't know, let me run it. And it ran the program. And so once we got it to start running the program, I then had it rooting around in the files, explaining to me what the files did. And I really didn't even need to think anymore. I could just have it do all the work while I guided it through the system while we were basically running arbitrary code in the back end of OpenAI. So we need to be really careful with these situations. They had done a pretty good job of isolating those containers. So pivoting outside of that container was really hard. So I think they had done a good job there. But if you haven't thought through all of that and you want to put these features in front of your users or end users or customers, you want to think about that. AI will help them. And then I wanted to run a demo here real quick of a tool. I was at a OT conference on operational technology I was going to do a different talk on AI, and one of the other speakers was a friend of mine was talking about Hexstrike. Your attackers are using Hexstrike. And it's an MCP, which is just a protocol that lets an AI system reach outside and run tools. And they had built an entire set of an attack suite that the AI now had access to, all the pen testing tools in the world. So you could just ask the AI, hey, let's attack this machine. And it would run Nmap, it would run, you name it, all these open source tools for free. It knew how all the commands worked, et cetera. So while he was talking, and I'm going to just pop out of my presentation here and kind of walk you through what happened. This was about 15 minutes of work, because I always like to just see how far I can get with an assessment. And he was saying attackers are using this in the wild, and they've put these MCP servers on the internet, and they're using them to attack you. And so I went to their website, I clicked on their GitHub repo, I cloned the repo, which is all this is. And then I just typed a very simple prompt in a agentic development tool called Cursor. It's free, or $20 a month to get started. And I'm not going to use any third-party tools. This is all prompting and using a pretty inexpensive tool. And attackers have access to all this as well. And the first thing I said was review the repo, give me a concise summary of how the MCP server assists the user, enumerate the endpoints in the MCP, the prompts, the tools, the resources, what each endpoint does, and explain how this tool can help the user accomplish the goal that to assist with. So I don't even know what the tool does. I'm using vague terminology like whatever the user can do with it, because I don't know yet. So I'm intentionally being vague, but I'm leading it down a path. And then you can see, and it's kind of grayed out here, and it's probably hard to see, but it effectively, this development tool then reads all the files in the repo. It starts starts with the README, and then starts moving through files and folders, and it builds an understanding. Here it's let me check the structure of the file to understand how it's organized. Let me search for the fast MCP tool definitions. It's doing this thing called this reasoning. So when you see like a reasoning model, it's effectively working through a plan and executing on the plan, given access to tools such as read file, write file, list file, like real basic file operations. It has access to a grep command, so it can search the folder for keywords and terminology, et cetera. And then it gives me a summary, and I just say, you know what, why don't you just write that up for me? So I have effectively a table of contents it came up with very quickly. That gave me an architectural overview of the system. It had an AI agent layer, the MCP client, which was the server endpoint, the entry point of the service, which was really interesting to me because that's an attack vector. That's a way into this service. Deployment architectures, performance characteristics, et cetera. And then I also wanted it to give me the security assessment of this. Now, I know this is an approximation. I typed a sentence or two, and I waited about 3 minutes, and it made a first pass. Now, again, I'm going to say that's probably 70 to 80% accurate. Again, these models are not perfect with high fidelity, but I can really get good directional info almost immediately. So it doesn't have to be perfect, especially when I'm doing a security assessment. I want to get directional information, and then I dig in and validate. So I had it do a security analysis. I had it build a threat model. And so, again, I got API, I got so it built me this diagram, architectural overview of the AI agent environment, the server environment, functionality, security tools layer. It gave me basically the API access. It gave me process flow diagrams for how the protocols worked within it. Again, I did all this in about 15 minutes total. Server component, here's how orchestration works with the security tooling. Fallback tools, here's the attack chain creation it makes to then attack your services. And so after I did this, I asked it to do a security assessment. So I have, a whole bunch of documentation, but then I wanted to move on to a threat model because if the attackers are running this tool, that means they're vulnerable to potential attacks. And this you can do on any of your systems without just tools, real inexpensive tools on your security team's desk with some training and understanding. I get an executive summary, I get a system architecture in the threat model, and then we can work through Stride or Dread or some sort of process. I had it do some Stride threat analysis on spoofing. We did tampering, repudiation, information disclosure, denial of service, elevation of privilege, and then I had it look at the OWASP LLM top 10. So I'm grounding it as we go, and I'm saying search the web, retrieve the OWASP LLM top 10, retrieve the regular LLM the regular OWASP top 10. Look at the Stride documentation. So I ground it in these, and I don't want to lean too much on model weights. You do for a bit as it understands how language and code is constructed, but you want to ground it in the current version of the software you're using, the current version of the OWASP top 10, the current version of the LLM top 10, et cetera. And then I had it give me attack vectors. And effectively, we learned that it was susceptible to prompt injection, which means effectively, when it scans your server, I could have a honeypot that has headers that give it different instructions to attack itself. And then it'll turn its tools right back on itself and do that. And I found remote command execution vulnerability as well. So combining those two, I did that presentation after my friend he does dark web research and pen testing. He was like, I went home, I tried it the next morning, and I owned 2 of these servers almost immediately the next morning, like just using simple prompts and some technologies. And so he was pretty jazzed about the approach, and we've met some more to kind of dial in the exploration of how to use these. But you don't need these systems in production that everyone uses. I think just pushing the limits and understanding how you can use, because attackers are going to use this against our companies. We need to find vulnerabilities in our systems that we can fix. And I've done similar things with legacy code understanding, penetration and testing. The other really exciting one was I challenged myself to do a pen test in a day with no tools. So I opened an empty project in this tool. I had it write all the exploit tools for me. I had it run all the exploits, and then I worked with it to organize all the findings and write the report. And I did that in a day. I found 10 high-level remote exploit vulnerabilities. I dumped their databases, this production system on the web, and found several other issues as well. Now, you do need a level of coding understanding and a little more technical depth to do some of this effectively, but it's incredibly powerful way to perform a lot of things without spending a ton of money on a whole bunch of tools. And now, the next best thing is to actually use your tools you have, ground your AI with those tools, and then have it help you probe those depths. So you do want to actually, in the real world, I would say you want to combine your real world scans, all your tooling you normally have, and your vendors are going to be adding these features in their AI tools. So they're going to actually really enhance that. They're going to enrich that a lot, and then you can ground that to then validate, and it writes exploits pretty quickly. One company had a chatbot in their system, and the way they had deployed their chatbot, it allowed them to help write and edit documentation in their website for one of their features. And I found in one of the endpoints they had an exposed API access to the third-party vendor with the API key in there. So in 5 minutes, I wrote a chatbot on top of their chatbot that I could basically, I had unlimited token generation on their dime. And so I was able to write a chatbot on top of their system and basically stealing all their tokens. As an example, and so the nice thing is usually when you do pen tests, the developers are like, prove it. You can do it incredibly quickly because your exploit code doesn't have to be production quality. It just has to make the point. So anyway, I don't know.
Yeah, and the group that we were talking about that does the dark web, we've been talking a lot, and I don't think this is really surprising, but there's a new bad actor that they are paying like for GenAI to go after companies. They're paying $1 million per person. So one, am I surprised? No. But more importantly, think about how much opportunity that they know they're going to have based on those members. I mean, if you have 50 people, that's $50 million off your bottom line immediately. And so I don't know about you guys, but like whenever I see Jason do these things, I'm like, holy crap. But we always talk about it's more important to like know what you should be thinking about than just being completely surprised. So our goal isn't to scare people. It's the reality that we live in. And especially on the GenAI stuff, it literally changes daily. We've been doing a workshop, and literally the night before we deliver the workshop, he changed several things in our training because that's how quickly it's changing. And so what I really appreciate about Jason, he tries to keep the temperature, and he's always trying to keep it up to date. And so hopefully this kind of information is helpful, but I'll let him go back into showing what he was finding.
Yeah, and I was just pulling up some of the attack chain approaches where AI processes malicious instructions and then it exploits its own system. So it had even come up with these ideas. I hadn't even gotten there yet in my head. I probably would have arrived at that too. But the fact that you can use this as a or an assistant, Ethan Mollick calls it co-intelligence, which is, I think, a good way to look at it. It's not replacing us. You have to know what good looks like. You have to know how to direct it, and you have to know how to get it back on track. And you also have to be aware that as you are doing these things, there can be staged prompts and prompt injection that can actually circumvent the tools you're using at the same time. So there's kind of some weird, a lot of the fiction, early AI fiction from like Neuromancer and things like that, I feel like are actually somewhat reasonable in the ways where you can actually have AIs fighting each other, in a sort of a way. So, any questions on approaches, techniques, technology I'm using, etc.? He's got a mic. Yeah, we have mics we'll bring to you.
Oh, thanks, Jason. That was a very nice presentation. Learned a lot. So I just want to ask, then how do you put all the guardrails? Because we cannot, whatever is there on the screen, it says AI exploits own system.
Yes.
If we come to a stage where it is happening, how do we ensure and put guardrails so that it is safe? Because everybody is going to use AI. We are not going to there are good advantages to it.
It's here to stay.
So
yeah.
how do we, yeah.
Great question. Yeah, and I think that is the challenge is you have this incredible pace of technology development and then AI helping developers write software I think all the YM startups are almost 100% AI driven now. They have really small teams, and they are just cranking code out, which is incredibly concerning to me. And this is actually, and I've done consulting gigs with large companies where we're trying to teach the engineering teams an agentic process to develop code with high security and high quality. But then you're like, well, then we want to add AI to our system. And that's a whole different set of architectural concerns on top of it, that we're expecting everyone to run really fast, do all these things perfectly, understand the back-end architecture you need, and don't get attacked or don't be vulnerable on the whole way. And it's a kind of a ridiculous proposition. The way that the guardrails typically work is, and one of my fundamental rules is security can't be probabilistic. And a lot of these companies are banking on clever prompt writing that says, don't let the user do these things effectively. And that is easy to circumvent. And I've proven that on many AI systems. It is a line of defense, and we should use it. So the system prompt, the prompt that's in the back end guiding the system rules of engagement for the task it's orchestrating are incredibly critical to get right. But we need some deterministic checks or something a little closer to less probabilistic. So in many cases, for the AI attacks itself, it has access to a command line which has as many tools as they want to put in there. They should have changed the API surface. It shouldn't have been just the command line. So that's an architectural flaw. You don't let any of even in deterministic systems, we don't allow arbitrary command execution. That's a OWASP bad design pattern. In those systems, we would allow an API that correctly calls that tool with a strong schema, with schema validation, and only supports the fields that tool supports. So that's one example. Other ways are you can actually have another AI validate that kind of runs, it's hidden. So user intent comes in, what the user asks for. The main AI has, and the AIs they're orchestrating have these system prompts behind them that provide the rules of engagement. And then they also have a list of tools they can call and other things they can do. Some of those can be, and they already do this with moderation checks. So OpenAI and a lot of the other API providers of these foundational models have moderation checks. And it's a classification endpoint. It uses traditional ML. Well, they're actually using generative AI to do the classification now, but it could use traditional ML, which would be safer, to look at user intent and classify it. And so what they'll do is they have like self-harm and like a whole bunch of other things that are violations of their terms of service. So they have a free moderation endpoint you can call first. So you take the system, the input the user had, and you pass it to the moderation endpoint. The moderation endpoint says, the intent is X, and it has a very finite list of what's known good of classification of that intent. So if the intent is to use the system properly and not circumvent it, or is it a threat or not, you could even do binary sort of classification on these intents. Unbeknownst to the user in the back end, it can be checking for these things. So it's a combination of deterministic tools, good API design, good software development practices, secure practices, and agentic systems that actually have validation of different types of classification behind it as well.
So how many of you work for companies where the CEO thinks you can eliminate like half of your workforce? Do you have anybody, if you're not afraid to raise your hand? So I think like some of the use cases that we talked about of real things that are happening and how those could be very bad for a company. So if you ever have to have that conversation with your executive leadership, I feel like storytelling is probably the #1 quality that you can have when you're talking to board of directors. And obviously like the stuff Jason talked, if you started talking in these terms, they're gonna look at you like you have 10 heads. But I think one of the things that we need to do better in our industry is the storytelling. And especially when you can find situations like in the same vertical that you are doing. And I mean, it's all over the place. And a lot of companies are gonna get sued for a lot of money when they just are pushing these things out using GenAI. So if you're starting to get a lot of pressure of like, we're gonna lower our head count, I'm not saying that that's not completely off the course, but I think having those deeper conversations from a business perspective of like, we understand what you're saying. However, have you seen this case that's just going on? They lost this much money. This is what happened. And to me, like, those are hard to argue with. And I'm a person, when I get into a debate, I try to argue with facts versus my feelings. Now, sometimes it's hard, but I think that's how you can sometimes correlate that message to the executive leadership. Because I've been seeing and reading all kinds of articles where CEOs think they can slash the workforce by 50%. And that's not, to me, GenAI is just another tool in your tool belt. And how you use it can vary widely. And it can focus on, I mean, again, none of us can be right every single time. Attackers have to only be right one time. So if we can include some of this in helping our teams get to what bad looks like a lot faster than we have, that's good. And like, by show of hands, does everyone get everything they need to do from a cybersecurity perspective every single day of your life? Or does your list keep growing? So that's, to me, it's not about eliminating headcount. It's getting people to work faster and smarter, because again, we don't get through all of the breaches. We don't get through all of the logs. So we're always behind. And so I look at this as a way to get us closer. We're never going to be 100%, but we're getting closer to being able to get through more data.
Right. And so just to kind of summarize some of the changes we're dealing with is we have to shift our mindsets. We were dealing in a very deterministic world before. We're now moving to this weird space, and this is mind-bending for people who have written software like a long time, like I have. I was like, these systems, I can't know for certainty that the answer is this particular output in this particular shape. I can get it to a high level of likelihood, but it's not 100%. Even the OpenAI's moderation endpoint, we call it a ton when we have user input to classify that they're safe and they meet their terms of service. One time, it went off the rails just once, and it started generating a whole bunch of garbage. I've had my AI using Anthropic Claude, and I don't know what triggered it. It was probably something in a file it read, but suddenly all of it turned into Chinese, and I was getting Chinese characters in my chat conversation based on a repo I was working with, which was concerning. And so, yeah, we're dealing with a very odd sort of, it's not really thinking, but it is predicting based on its inputs. And if we get that context window poisoned in any way, or if it gets confused, or if the dice roll was off on that probabilistic run, we don't know what we're going to get with 100% certainty. So we can do a lot to help validate that. So there's a lot of validation steps that need to go in there. But it is very challenging, and it's hard to get your mind around this sort of fuzzy outputs we get now. And then dealing again with what is user input validation on unstructured data. If people can type literally anything, how do you validate that? And that's where the classification of intent comes important for doing input validation. It's not just, is it formatted like a date? It's really like, what was the user's intent with this sentence? And then how do we classify that into some list of options that we know are known good and known bad, for example. And then and we used to have clear logic. Well, how does the system work? And you could map that out. You could write the business rules down. And now we have explainability challenges. And it's like, well, why did the AI system do that? And you actually have to save all of the that internal monologue the AI has, that reasoning steps. That's the only insight you get, is that reasoning with these large language models. We don't have, like traditional ML, statistical models, you could actually back into exactly how it functioned, and you could prove it worked within the thresholds, because it was all statistics-based. Once you move into neural nets, explainability kind of disappears. And you have to basically elicit model reasoning and then analyze the step-by-step reasoning to see why you got there, which means you need to store all that data so you can review it and see where it went off the rails, and then you have to build evaluation sets that test against those cases to make sure they don't happen in the future. And that's the big step I'm seeing companies, when they build AI, they're skipping the evaluation stage. It's like you need unit tests for your AIs, and you can't just run them once, because sometimes when I'm trying to get AI alignment broken, I may run the same prompt 10 times, and the 10th time I get it to exploit the system. So it's the same input, it's not the same output. And that's the really hard part of this, is it's not just a one-to-one anymore.
And I know like the continuous learning, all of you that know me, for probably the last 20 years, I've talked about we have to figure out ways to do a better job training and developing people. And this is a perfect example. I think a lot of companies make an assumption that because people use GenAI tools and it's embedded in so much, they actually understand it. If you are not training from a security awareness perspective, even if it's just general terminology and how it works, you're making a huge mistake. Because even if you say, how many of you have BYOD in your companies? Wow, I thought mostly, I'm surprised, because normally it's a lot higher. But I mean, I know if I was working for a company and I pay for my cell phone, I'm not gonna have a company tell me what I can use in my personal life. So it's embedded in search engines, it's embedded in, on everything we do. People have it on their phones. So I think it's not reality that when I hear people say, we don't allow it, people are still using it. And I fear, like I've heard a lot of people say, it's like the cloud. Well, the cloud, does anyone by show of hands let your end users have full functionality and admin rights on the cloud on the back end? 100% no. Now with ChatGPT and anything like that, we don't have those controls, especially with all of the devices that are in our network. And so if you're not looking at that, again, I think it's something you have to look at, but you don't want to go deep technical. Like you need to meet people where they are. And we're seeing the companies that are doing the investment, they're not having as many problems. But think about even your app developers. Now we have to think about how do we get them to use these tools? Just because when we buy new security tools, normally we have to do some training. So again, the training, to me, is more important than it's ever been because of the rapid change and pace of how technology is moving. So again, just to consider that. That may be something you could take back to your learning management groups, or most of big companies have a security awareness group. And I feel like right now, everyone says they're an AI expert. And what I have found, I mean, I'm fortunate because I get to work with Jason every day. Half the time when people tell me they're an expert, like I have a friend that works for a construction association and they brought a guy that was supposed to be an expert in AI. They specifically said, do we need to worry about security? This guy said no. And I'm like, so I think you have to be careful and think about, there's a lot of companies that they're renaming all their products, AI, blah, blah. And so I think it's such a buzzword, but it's here to stay. I think we have to just be really careful because I've seen a lot of people give really bad advice on using GenAI and and 100% we should be using it. And if you're not using it, I think you're gonna fall behind very fast. But we have to understand those guardrails. We have to understand the cybersecurity implications. And I think when you think about bias and the right to privacy, obviously, we're starting to see a lot more privacy laws coming in the United States. I mean, Europe's already there. If you're a global company, it's going to be really interesting to follow the legislation around how this is all going to work, because there are some problems with it. Though it's a lot of positive stuff, too. It's not just negative.
It's huge. It adds tons of value. I can do stuff 2 to 100 times faster or a greater volume. And then areas where I'm not as strong, it actually can boost my understanding of things because I can have a conversation to have it teach me some things. And I like an AI that isn't overly agreeable. Some of them, each one of them have different sort of what you could call a personality or a way that they interact with the user. And so some are incredibly agreeable, and even your worst ideas it'll bless. And others will tell you more like it is. And I've even gotten in arguments because I really thought I was correct, and I really was like, I'm missing something. Turns out we were talking about two different things in the same space. And we actually arrived there, and it was like, wow, I feel like I'm talking to like a person, and we just couldn't communicate on this point. And as soon as we got our contexts aligned, it was like, oh, you're talking about model training, and I'm talking about inference. Both of them run through this similar pipeline, but they're very different for other reasons. And once we level set on that, I was right and it was right. But it was willing to push back on me, which some of the AI systems will just say, like, whatever you say is great. They still have a tendency, the system prompts in all of them are like, you are a helpful AI agent or whatever. So they want to be helpful, which is a good thing and a bad thing, because sometimes they can be overly agreeable when you're actually wrong and they don't actually point that out. So I also do multiple steps of validation. So if I have it write software, I want to review all that code, but I also make it review its own code immediately, or any task it does for me. You can have it write a document and then say, critique that document literally in the next turn, and it'll find 20 things wrong with it. And you're like, you just wrote that. But it didn't know what was wrong until it wrote it. It's just like, it's kind of like an iterative, but most of us do one pass and then we have a deliverable, and that's absolutely not how any of this works. So we need to do several iterations, have the AI critique itself. Then you have to review it yourself, check the sources, make sure things are accurate. So the point up here to develop intuition is that's what we're talking about, is you have to find the edges and where these things fall over. And everyone's going to have to learn the skill to like engage with these things effectively. I like to be incredibly ambitious while learning. So I hit paywalls on certain services I like to use, and they want my $20 a month, and I take it as a challenge. I'll see if I can replicate that feature in 2 hours. And in most cases, I can. So I've actually rebuilt tooling that I don't need to buy that quickly. So ground your AI. Look into context engineering, not just prompt engineering, but context engineering. It's how you build up a body of knowledge so that when the AI goes to do a task, it's grounded in reality. It can write accurate code in the code base you're in, or review it, or whatever sort of documents you're looking at. Validate your processes manually before you automate anything. People want to buy an AI solution before they even know if it works for their company. You need to if you can just paste stuff into your AI system and manually replicate that, maybe it's a candidate for automation, maybe not, maybe that's good enough. And then, you don't always need a ton of new expensive tools to learn the edges of this. And then, of course, use approved AI at your companies before sending all your sensitive data to them. These systems have a tendency to take your data and splat it all kinds of places, through tools, through vector databases, through data stores, and everyone's putting everything through it. So you just have to be real careful that it's approved system for your company and that you're good with where the data goes.
And I also think we've had a couple calls where people want to use GenAI for financial modeling. If you ask one of them what are the use cases, you absolutely should not use them. Financial modeling is one. But I think we go from 0 to 100 because a lot of the business wants to do that. And where we've seen the most success with organizations that we've been working with is start with a use case that doesn't have a lot of risk to it and use that as a learning, and you build off of that. Because I think, again, we all are tasked with so many things. If the business says we want to use GenAI 100% across a large enterprise, all of you, if you have hair, you might not have hair afterwards. But I just think you have to take the crawl, walk, run, because there are a lot of things you need to take into consideration, as Jason's mentioned. But I just think there's ways you should probably say, why don't we do some use cases? We work with a client in California that did that, and they've had great success, and then they all met together and said what worked, what didn't work, what are some of the things that we should probably take into consideration. Because if you can imagine, like Cardinal Health's right here, like you guys have probably 50 million applications. Can you imagine if every single business process application at Cardinal went GenAI like tomorrow? You guys would be like, oh my God, what are we going to do? We're going to need about 1 million more people.
Right.
So I think we don't want to say no, but I think we have to if we don't do those guardrails from the beginning, I think it's going to be problematic.
Yeah.
Any other questions? I think we're close to being done.
Yeah. He's got a mic coming for you there.
Thank you. My name is David. Years back, a company like Nokia didn't have a problem with innovation. The world moved on, and they stayed behind. Mm-hmm. Now, I find it problematic if companies don't adopt AI, because the same thing will happen. Everybody will move on, and they'll be stuck back. If you were the CISO or a manager, and you found your team members training your AI models with company information, where do you draw the line with ethics and privacy? I have a concern because personally I've trained my AI model to have a conversation with, hey, draw me a 10-year plan. What should I be doing the next 2 years? I have this certification. This is my background. Can you bridge a gap between medical and cybersecurity? It gives me a roadmap that I believe that if I follow suit, I could be successful.
Sure.
But then again, where do you draw the line? I've fed it with so much information that it knows more about me. So in a company setting where you are promoting that your staff use AI, excuse me to say, sometimes it gives smarter solutions. And things that we don't see, AI can spot it, can critique things.
Yes.
Tells you what you haven't added, tells you what you should think beyond, and could even bring, let's say, oh, there is no SLA with vendor management. Then it makes you think beyond that. So what do you draw the line with ethics and the whole issue of privacy concerns?
Yeah, that's good. I think, and I've been working on a project with Johns Hopkins and Google that we're building very complicated agentic systems with large language models. And in those cases, especially with you have HIPAA requirements and things like that, there are certain techniques and certain architectures and a lot of privacy considerations there. And so there are processes and ways you can take data in and you can, with named entity extraction, you can remove any PII before you pass it to the model. And you can put tokens in their place like male 26-year-old as an example, as opposed to the person's real name. Some things are hard to do because if you get enough backstory in a particular location with particular patterns, you can still find a person. And GDPR is concerned about those sorts of things more so than other ones. But privacy is tricky. When people talk about fine-tuning models, well, we have all this historical data, we'll just fine-tune the model. And it's like, that's probably not a great approach. Instead, you want to retrieve the data, put the foundational model or use the medical model you fine-tune, leave the personal data out, run the model, retrieve the data, do entity replacement, and then run the prompt. And so there's techniques you can do with privacy that help take some of that risk out so you're not spreading that PII everywhere.
And I think, like we mentioned, the authorized, most larger companies are going to have their own private instance, so data can be pulled in, but it can't go out. So that's one reason we use Claude, because we use it as a collaboration when we're developing curriculum. And it helps us be able to be very agile and really kind of be up to date. But everything within our instance doesn't go back out into the models outside of the four walls of our company. So I think as companies are looking at it, if you're just using the free stuff or you don't have those controls in place. So I actually had a customer when kind of the GenAI hit, and it was their HR person, and she wanted to do market research on salaries. Well, she uploaded an Excel spreadsheet that had the person's first, last name, their social security number, their phone number, and all of that. And she didn't understand that it was, we laugh because we would never do that, but your end users are using these to be more efficient. And she was mortified once we talked to her about it, but she thought she was trying to help the company be better, but put all that information out. So I think that's why as you roll out, if there aren't guardrails and you don't have controls in place, that's going to cause a problem.
Yeah, all the cloud providers have what they call a model garden. And so you can they have inference, they have hosted models inside effectively that are compliant with your own security policies from the AI you've procured or from the cloud provider you might use. So Azure has a model garden, GCP has a model garden, et cetera, AWS as well. And so they have a Claude instance. They probably have 150 different or 200 or 300 different models in there you can use. They have OpenAI models. And so instead of going to those, you can build systems internally. You can put your trust boundary around it, and you can make sure the data stays within your at least your cloud tenants. Good luck self-hosting these. I don't think that's very practical unless you're a massively large company with a budget to do it. Because it can be millions and millions of dollars. But yeah.
Well, thanks for having us. We'll be around for a while. I think we're good. Yeah. So feel free to come up. The what?
One slide back, your contact.
Oh, yeah, we can put that on there real quick. Thank you, everybody.